All right, we're going to do the second half of Chapter 6, Section 2 in this lesson. You're going to notice in this video I'm going to cut out a couple sections that we maybe touched on in class, but we're not going to include that for you guys in the quiz or the test. The main difference between this lesson and the last lesson is finding the trig function of an angle given a point in the coordinate plane, right? So up here we see let theta be any angle in standard position and let the point P be a point on the terminal side of our angle, right? So if you look at our graphs at the bottom here, right, we have 4 graphs. We have one in quadrant 1, 2, 3, and 4. Notice that no matter where you plot a point in the coordinate plane, you can always connect the origin to that point and have that, treat that as the terminal side of your angle theta. And remember, standard position just means you have an initial side on the positive portion of your x-axis, right? So right there, and all of these, right? So all of that is the positive side of the x-axis, and then you have your terminal side, which can be really anywhere on the coordinate plane, right? So I have a side, another side, another side, and another side. And similar to how we drew those special right triangles in the coordinate plane, you can really draw any right triangle in the coordinate plane given a point x and y, right? So notice that if I draw a point right here and I connect that point to the x-axis, right, we get a little right triangle, and that's true for any quadrant, right? I get any quadrant, I get a little right triangle. All right, and then also notice that if we treat this angle right here as our angle of interest where we're doing all of our trig functions, our opposite side is always going to be y, right? Same thing right here, y, and then I'm missing one right here, right, y. So all of our opposite sides are going to be y, and then all of our adjacents are going to be x, right? X, and x. And then the hypotenuse we can treat as the radius, right? So I think in class I briefly mentioned the unit circle, right? So all of these points that we're drawing on the coordinate plane kind of relate to this imaginary circle, right, with said radius, right? So it doesn't really matter where the point is, you can always draw a circle centered at the origin with some radius, which we can treat as the hypotenuse. All right, so this is the only difference between this lesson and the last, is that now instead of using SOHCAHTOA, right, you guys can still use SOHCAHTOA. That's going to help you. You guys know sine as opposite over hypotenuse, right? But in this lesson, we're going to treat it as y over r. For cosine, our adjacent is going to be our x, and our hypotenuse is still going to be r. And then for tangent, our opposite is going to be y, and our adjacent is going to be x. All right, and then you guys have also learned about cosecant, secant, and cotangent, which are the reciprocal of our sine, cosine, and tangent functions, right? So this is going to be r over y, right? So hypotenuse over opposite, right? And this is r over x, secant. It's going to be hypotenuse over adjacent. And then our cotangent is going to be adjacent over opposite, right? X over y, right? So if it seems a little confusing, I'll do some examples that I did in class, and then hopefully we can kind of piece everything together. All right, so let's look at this first problem. We see that the terminal side of an angle theta in standard position passes through 815, and we want to find the 6 trig values of theta. All right, so I would draw this just to see where it is in our coordinate plane. And 815, if x is 8, that's somewhere right there, and I'm just going to label 15 as somewhere up here. So then I get a point right there. This is in quadrant 1. All right, and in the first quadrant, both x and y are positive. All right, so I can go ahead and draw the terminal side of my angle somewhere right there, and then I get a right triangle by connecting that point to the x-axis. All right, little off center, that's fine. And that's our right angle, and then this is our angle theta. So we have my opposite is going to be this vertical component, which is going to be my y, right? And we know that y is 15. And then my adjacent is going to be this horizontal component, which we know that that's our x, right? All I need now is to find my hypotenuse. And to find my hypotenuse, I can use Pythagorean theorem, right? So we can use a squared plus b squared equals c squared, but just to relate it to the coordinate plane, I'm going to use the formula that was shown in the previous slide, and I'm going to say x squared plus y squared equals r squared. All right, so x squared in this case is going to be 8 squared, y squared is 15 squared, equals r squared. We should get 64 plus 225, right? You guys get calculators. And then we get 289 is r squared, right? So we take the square root of r squared, and then we get r is 17. All right, so now that we have all of our sides, we can use this to fill in the 6 trig functions, right? So starting with sine, so sine of our angle theta is going to be opposite over hypotenuse, which in this case is going to be y over r. And our y value is 15, our r is 17. Right, cosine is going to be x over r, right, or our adjacent over hypotenuse, that's going to be 8 over 17. All right, tangent is going to be opposite over adjacent, so y over x, which is 15 over 8. All right, and then to find the reciprocal trig functions, right, just take the reciprocal. So I get cosecant is r over y, which is 17 over 15. I get secant is r over x, which is 17 over 18, or 8, sorry. And then we get cotangent of theta is x over y, which is 8 over 15. All right, so essentially the same as we did before in previous lessons, just looks a little different because now it's actually all relating to the coordinate plane. All right, so we could try the same thing in the next problem, right? So draw a coordinate plane. We have a point -3, -4. So -3 on the x and -4 on the y, that's going to be somewhere right here. All right, so we can go ahead and label this as this distance right here is -4 since that's our y. This horizontal distance is -3 since that's our x. And then this line right here, this terminal side, we can say that this is r. And again, to find r, it's going to be x squared plus y squared equals r squared. Right, so you can use Pythagorean theorem. That's going to get you -3 squared plus -4 squared, which is going to get you 9 plus 16, which is 25. And so to get r, you just square root, and then we get r is 5. All right, so now that we have all that, we can find our 6 trig functions. All right, so we can start with the ones that we already know, sine, cosine, and tangent. So I know sine has to be y over r, which is going to be -4 over 5. Cosine has to be x over r, which is -3 over 5. And then tangent is going to be y over x, which is going to be -4 over -3. But since they're both negative, we make them positive, right? So +4 over +3. All right, and then for cosecant, secant, and tangent, just take the reciprocal. I'm sorry, cotangent. So cosecant is going to be -5 over 4. Secant is going to be -5 over 3. And cotangent, since we already know that tangent is positive, cotangent is just going to be the same, right? But just the reciprocal. So +3 over 4. So this new way of classifying or evaluating, the trig functions using x, y, and r might seem kind of unnecessary if you know how to draw a right triangle and you can label a squared, b squared, c squared, and do SOHCAHTOA. But sometimes there's some angles where you just can't draw a right triangle, right? So if I look at this circle right here, and you'll see why it relates to a circle, right? If I draw a right triangle, right? If I pick a point right here, and I say this is my radius, and then this is my y and my x, right? We get a little right triangle right here. As you can see, based on these points right here, right, our radius is going to be 1, and then we can figure out what the rest of x and y are just based on the point that we're given, right? But no matter what point we pick here, our radius is going to be 1. All right, but think about if we pick a point right on the x-axis, right, and I try to make a triangle out of that. Well, you notice that you can't really do that because this is just a straight line. Same thing if I pick a point right here where it says 90 degrees, I try to draw a right triangle, but that just gets me a straight line, right? And that's true for any quadrant, right? If I pick a point at the 180 degree mark, you can't really draw a right triangle out of that. So it's good to relate it to a circle with a radius, so that way we at least have a radius of 1 in this case, and points x and y, right? So if I want to find the 6 trig functions of our first example here is 90, right? Then I just label this point as x and y, and then I do my points accordingly, right, in terms of x, y, and r. So sine of 90, I know that sine has to be y over r, and that's going to be 1 over 1, which is 1, right, because this point at 90 degrees is 0, 1, and I know this is a circle of radius 1. All right, and then I have cosine of 90, that's going to be x over r. I already know that at the point at 90 degrees, x is 0 and r is 1. 0 over 1 is just 0. Right, now if I want to find tangent of 90, I know that that's y over x, and I know y is 1 and x is 0. Anything over 0 is undefined. Right, so this does not have an answer for tangent. All right, but these are values that we would not have gotten if I had tried to draw a right triangle, right? You wouldn't be able to know what's what. All right, so that's where this is useful, our x, y, and r. So for cosecant, of course, that's just going to be the reciprocal, r over y, which is going to be still 1 over 1, which is 1. Right, and if I want to do secant, that's going to be r over x, which is going to be 1 over 0, which is also undefined. All right, and then if I want to do cotangent, that's going to be x over y, which in this case is 0 over 1, which is just 0. All right, so we can do the same thing with sine, cosine, tangent, and so on of 180 degrees, right? If I look at the point right here at 80 degrees, negative 1, 0, right, that's just a straight line, right? I can't really draw a triangle out of that. But I do know that it's a circle with a radius of 1, and it's on the coordinate plane, so I can label an x and a y. All right, so we can go ahead and find the 6 trig functions of 180 degrees using x, y, and r. So I know sine is going to be y over r, which in this case is going to be 0 over 1, which is 0. Cosine is x over r, which is going to be negative 1 over 1, which is negative 1. All right, now tangent of 180 is going to be y over x, which is going to be 0 over negative 1, which is just 0. Right, now with cosecant, secant, and cotangent, just take the reciprocal. For cosecant, I get 1 over 0, which is undefined. All right, for secant, I get 1 over negative 1, which is still negative 1. And then for cotangent, I get negative 1 over 0, which is undefined. All right, and you can do this process for any angle that's on a quadrant, right? So if I wanted to do 270, right, as long as you know where 270 is, you can say that this is a circle of radius 1 and a point x of 0 and y of negative 1. Same thing with 0 degrees, or this is the same as 360 degrees. All right, so that's going to be an x value of 1, a y value of 0, and we can still say that this is a radius of 1. All right, so you guys have seen this before, our reciprocal identities. We're just saying that sine, cosine, and tangent is the reciprocal of cosecant, secant, and cotangent, respectively. All right, so now applying that to a problem, if I want to find cosine and I'm given secant, all you really have to do is just take the reciprocal. So I know that cosine of theta has to be 3 over 5, right? Because cosine and secant are reciprocals, right? Easy as that. And now for cosecant, I know cosecant and sine are reciprocals, so if I want to find sine given cosecant, I just take the reciprocal of what I see for cosecant. It's going to be negative 2 over square root of 6. And then this, I can rationalize that denominator. So then we get negative 2 square root of 6 over 6. And then 2 and 6 can simplify. So then we get negative square root of 6 over 3. All right, and that's all you have to do for these problems. And that's all in this lesson that we're going to quiz you on. I think I went over some more stuff in the lesson when I taught it in class, but that's really all you need for this lesson.